Hi everyone, good morning, good evening. So today we are going to learn about application insights profiling. So let's start. Before we start, quick intro about myself. Oops. And thanks Rohit, for the nice video. And yeah, I am Praveen Shiva. I'm working as a cloud solution architect and developer. So that's a quick intro about myself. And yeah, today our topic is profiling using application insights. So before we dive into uh, different stuff, so let's understand what is profiling. In software engineering, profiling is a form of analysis, some kind of analysis to a code that measures different metrics like CPU percentage, memory that our application is consuming. So is I copied the definition from Wikipedia. So today we are going to learn how you can profile an application running inside Azure with the help of a service called Application Insights. It's very easy. You don't have to install anything on our own. And all the tools required for profiling the application are built into Application Insight service out of the box. So let's dive in. So today we are going to learn about overview of App Insights. Before we do profiling, we first understand what is App Insights and how it fits into various components in a built-in project. I will just take a simple application with various components and I will show you where App Insight fits in that application. And then we will discuss about some of the App Insight features that can be used to review our performance. And then we understand how to enable profiling. There are different uh, things that we should do. It depends on whether it is Windows operating system or Linux operating system. Right? We will understand what are those differences. And then we will see. We will try to see if we can simulate some traffic. We already simulated some very basic traffic, that would require to do it again. So let's first understand what is Azure Application Insights. So if you look at this diagram, this is Application Insight Service. It's a PaaS offering by Microsoft. Now, once you create this Application Insights, uh, it provides us, it automatically tracks the application telemetry and any other custom application logs that our apps would push, right? So if you see this diagram here, this is a front end, probably an EC based application. It could be an Angular application or it could be any other application. So all we need to do is we need to install an instrumentation package. For .NET, it's a NuGet package. For Angular, it could be an npm package. For Java, it could be some kind of package. Right? So developer needs to add that package and write one or two lines of code. That's it. All the telemetry, everything will be automatically pushed to App Insights asynchronously. So we can integrate App Insights into our web applications or APIs or even background services. It could be any console application, a background application or example application, anything. So once we integrate that, the application will start pushing the telemetry logs to App Insights. And from here, basically this App Insights store all the data. Of course, it provides many built-in reports. We can analyze the data and we can get insights about our application performance, exceptions, top three exception reports, response codes, top three slow running pages. All that information we get out of the box from application insights without we creating any reports. Now, apart from using the default reports, what we can also do is we can do all this. We can create alerts, we can create custom reports using Power BI, we can export the data and put it in somewhere, and we can do uh, further analysis, all those integrations are possible and they are seamless to integrate. Okay? And so this is a simple application that I have developed wherein we create various services. I already created all these services. The web application which talks to a database, and web application also talks to some storage. These are all Azure services, and it talks to an API. It could be our own API or it could be an external API as well. And probably we are using some base cache. Right? So in real time, an application or an API can talk to many different services. Right? So now probably you want to track the performance of each of the calls made to all these services. So probably our web application is making some database calls, database strips. Our application might be uploading some files to storage account. Storage is another service in Azure. And our application might be talking to an API using HTTP client. It could be our API or it could be an API managed by someone. So now we want to track all the exceptions, logs, performance metrics, everything. So all that can be done very easily with the help of App Insights. All we need to do is link our web app with App Insights with the help of a connection string, with the help of a key called instrumentation key. So every App Insights will have a unique instrumentation key that should be plugged inside web application. Along with that instrumentation key, we also need to add the NuGet package in just one line of code. We just need to register app application inside telemetry service in our application. That's it. So now whether web application is making calls to storage, database or APIs, automatically all the calls are tracked out of the box by App Insights without rewriting any code. And unfortunately, there are some services which are not tracked automatically. For example, Redis. So as of today, the calls that you make to Redis are not tracked automatically by App Insights. Probably we should write some custom code for that. Right? Even if there is another service called Key Vault, so those Key Vault is tracked by our App Insight automatically. Right? Not everything is tracked automatically. Uh, so there are some services like Redis Cache whose calls are not tracked automatically by App Insight. Of course, you can write your custom code uh, if you want to log those metrics, performance metrics, or anything else. So you have to write your custom telemetry for that. So let's explore the code. It's very simple code. So let me switch to my Visual Studio. I'm using a .NET Core 3.1 application. And if you look at here, this is my web application. And I have installed a NuGet package. So this is specific to .NET Core. But similarly, if you are using Java based or PHP based or Angular, very similar. Uh, in similar way, you have to download the appropriate packages. So this particular package is sufficient for tracking everything except profiling. So for profiling, we have to add additional package. These two are required for uh, profiling or application. So once you add these libraries, you will have to add the instrumentation key. This is the instrumentation key for our application insights. And then we have to add one line of code to track all the default telemetry for App Insights. But if you are interested in Profiler, you have to add this line of code. That's it. Now, the entire application, whatever calls it application makes, all those are tracked asynchronously. So, adding application insights will not add any additional load to our web application. There might be slight load, but it's negligible because all the telemetry will be pushed asynchronously to App Insights. Okay. And once you add this in startup class, so all you need to do is in controller classes, action methods, you just need to have iLogger and you can use iLogger wherever you want. For example, you can track the exceptions, you can push these exceptions in case if there is an exception, these messages will be pushed. You can also uh, log your custom messages as well. Just one line of code. Logger dot. You have various methods for various messages, log critical, log debug, log error, info trace and one. And all of them are available. Right? But for profiling, which is our topic today, we don't have to write any line of code except this. Right? Now, in order to show some code, I have added some thread dot sleeps in the middle. But in real time, there could be a lot of complex logic in your application. So there, in case if the developer did not write the code properly, all that will be uh, shown in the profiler once you enable it. So this is the code that I have written. I have a couple of controllers. And I'll be running this application very soon. Uh, let's go back. Now, before even we talk about profiler, I would like to explain some nice features where we can get performance metrics. If you see this application, this is a screenshot taken by one of the features called application map. Right? So I will also show you the screenshots on how to navigate to this application map feature in the portal in just a moment. But this is the application map. If you see this, these are application web application uh, which is talking to database. If you see this, there are 10 calls made by this application in this screenshot, and some of them are failed. I think 11% of them are failed, and 10%. If you see this, 10% of the database call were failed, and it was taking 11.2 milliseconds on average. Some of them might have taken more time, and some of them might have taken less time. But overall, on average, this is what the database calls, which looks good. But in case if overall, by looking at this application map, you can see where exactly the performance bottlenecks are, right? So here it's making a call to storage, and the average amount of time is 32 milliseconds. So at a high level, uh, when our application is talking to multiple components, here this view gives us which component calls are taking time. Right now everything looks good, but in real time when a lot of code is in place, and if it is not optimized code, then looking at this view you understand, okay, calls to storage are the culprit, or calls to database is the culprit. And this is one view where you can get insights about performance. That view is called as application map, right? And now this is at a very high level per component. But what if you want to analyze an individual transaction, right? Individual request? That request might be making calls to multiple components. Probably it is uploaded to storage, and once the file is uploaded to storage, probably it is making a database update, and once that is done, probably it is making call to another API. So a lot of components might be involved in one transaction or one request. So how do you do that? Right? So there is one more feature called distributed tracing. Right? So I have captured a couple of slides. So this is one request. So end-to-end transaction. Right? This feature is called as distributed tracing, wherein you track a request, and you see this is web application, and this is my action method. This is a URL which made calls to multiple different components. Of course, there were errors in the middle, right? But it made calls to storage multiple times. These are all storage account calls, right? And then you have a call to database in that SQL server. Now here, if you see this, it is giving us duration that it took for every other entity. Right? Here you are seeing empty spaces, but if you click on this, in the right hand side, you will see what exactly that call is. I was trying to create some storage related components. So it was taking around 49 milliseconds for that operation and so on. Database call was hardly 2 milliseconds. But now there is another view. It's a single request which is making a lot of interactions with various components. Right? Overall, it took 10.2 seconds. But if you combine all this, it hardly comes to 1 second. So where is that next 9 seconds? That's the problem with this approach. So that 9 seconds or 10 seconds is my wait sleep time. So I intentionally added some sleep. So that sleep is not shown here. But otherwise, this distributed tracing uses lots of insight about various components that are being interacted in that particular single request. This is another view where you get performance numbers. Right? In the previous view, you get a you get insights about average metrics, average numbers for an individual component. But here, for a given request, you get the actual amount of time taken for each component. If you have more components, you get all those here in a sequence. Right? But this is not giving some information about the calls which are not supported. For example, if this call had made a call to interacted with Redis, that would not be shown here. So at this point of time, Redis calls are not supported yet. Right? So that is where profiler comes into picture. Right? So if you see this small icon, this is a profiler icon. So by default, you don't see this. You see this only when you enable profile. So if you're not happy with these numbers and you still want to research further, you can click on this link. It will take you to another view where you can see more details. For example, here you don't see how much time framework is taking. .NET framework is taking for doing some other operations. Right? Here you don't see UI execution. But when you click on this, it shows all that. Of course, profilers are not 100% accurate because it's just a sampling. It captures only a sampling data. We'll talk more about that in the upcoming slide. I have a separate slide for that. So now this icon is shown only when you enable profile. So how do you enable profiling? So navigate to your app insights, and profiling can be enabled by navigating to a blade called performance. So click on performance and you will be taken to this blade where you see profiler. Click on that. It opens up a pop-up. It opens up another blade. In this slide you see that as a pop-up. But in the portal you see this pop-up somewhere in the right hand side. Now if you see this, these are the two recent profiling sessions. It is triggered on demand. I manually clicked on profile now, and it is one-time policy. I'll show you what policies are. And this is the app name, this is a server name, and this is the time. And there was no load during that point of time, but it will also show us if there is load while the profiler is capturing the data. Then it will show us how much CPU, what was the CPU load while that profiler session was running, and memory load as well. Right? So you can configure some policies here. You can instruct App Insights on when to start profiling session. And if you want to do it right now, then you can click on this profiler as well. And sometimes profiler will not work properly. So in that case, you can use this button to troubleshoot further. Right? So, yep. So now these are examples that I have captured, because sometimes profiler doesn't load up for various different reasons. But if you see this, this is one of the profiler traces for one of my calls. Right, I'm making a call to external API. So this is the URL for external API, and it has taken 14 seconds approximately, out of which 10 seconds is sleep time. It is giving us all the complete data. And if you observe this, these are These are hard paths. You see these flames. So when you come to this trace, profiler trace, it directly shows us that this particular request or this particular section has hard paths, and this is where you should troubleshoot further. And these are good. Right? These are some other framework related stuff for front end execution, but this is where most of the time was consumed for this particular request. And this is the actual wait time. It waited because I have added a sleep time, and it has waited because it is making an external call to some other API. So overall 10 plus 3 seconds, it shows 13 seconds. Right? Out of 14 seconds, entire 14 seconds for this request, 13 seconds were almost wait time. So this is how uh, Profiler helps us in quickly get insights about the performance of our applications. This is one example. I have one more example where I made some calls to database. And this is our .NET code, which is calling entity framework and internally calling the store procedure. So this took around five seconds, wherein unmanaged code, right? This is unmanaged code is a catch-all category which contains a lot of other things like multi-code, some dependencies. So here it took 2 seconds. Probably it is database took approximately 2 seconds to respond. Yes. This is another example. This is another example for storage. So these are application code and this amount of network latency probably. So this is how Profiler helps us in tracking all the performance issues. There are multiple different views in which application insights can be used to look at performance issues. Of course, there are some limitations or issues. Sometimes when you run Profiler, it will fail. Uh, right? So you have to retry again, and it only supports app services hosted in app service plans which are either basic or above. So sometimes even basic won't work, but standard or above will definitely. So these are the pricing tiers of app service plans in which web applications are hosted. So when many people think that profilers will hinder the performance of the server, but it's not completely true because the profiler runs only for 2 minutes every 1 hour. Of course, you can change it to 1 minute or 3 minutes, but otherwise it's the default is 2 minutes per hour. So it doesn't run within our application, but it's output it, so it doesn't impact the performance of our application. So let's look at that application. Sorry, let's look at the Azure portal. All right. So I am inside portal.azure.com, and I already created the services based on the architecture that I have shown in the PowerPoint. So this is my application insights, and this is our web app service web app, which is inside this app service plan. The app service plan pricing tier should be basic or standard or above. Microsoft says it's basic, minimum is basic, but I generally try that in standard. Okay? Because in basic or higher tier, you get a dedicated virtual machine. So Profiler doesn't work in free tier. So in case if when you try to turn it on, if it doesn't work, then you should upgrade it to standard. You don't need to. And this web app is talking to database. It's talking to another app service, which is an API, and then it talks to storage as well. Right? So let me show you application map. I give it a shortcut in my dashboard. So we are inside application insights, and this report is running for last 24 hours. So this is a view. It's a very nice view at a very high level. Uh, it gives us all the metrics about various interactions with various components. Let's say your app might be talking to multiple storage accounts. In this case, I have only one storage account. In that case, this becomes a cluster, right? And you can drill down further by that particular node. Well, now you can do that. So we'll see more details about this. If there are multiple storage accounts, then you will see all of them. And if you are interested to see what went wrong here, you can click on this and it shows us what those calls are and why it was slow, right? You can click on this and it will take you to different place and you can investigate the performance further. This is one view. The other view is end-to-end transaction, right? This view gives us at a high level per component. But what if you want to look at individual transaction? You can either click on this or you can click on performance. This particular blade will give us details about all different requests. Right? Again, this is filtered by 24 hours. You can of course change it to 30 minutes or whatever. So let me scroll down a bit. Now you see this. This is the average duration amount of time that it took. So far, this was called only once, and it took 13.8 seconds. This was called 6 times and it took an average 10.5 seconds. Now, if you want to understand and see what happened for individual 6 requests, individually for all 6 different requests, right? So click on that. On the right hand side, you will see all those 6 individual requests, or you can directly go to profile tracing. So out of 6 requests, the profiler was running only uh, while those 3 requests were happening. So this icon or this button will be shown only when profiler is enabled. This will not be shown when profile is not enabled. You will see only that, only this. So now if you want to see the load on individual components, then you can click on this. So you can pick one of them. Automatically App Insights suggests us to look at this, or you can see one of them. You can look at one of them. You can sort based on date. If you want to see the latest one, you can sort it by date. You can click on any one. Now this is end-to-end transaction. If you see this, I click on this. I think Microsoft guys have added this recently. Earlier we were not seeing this. These were individual calls. Like I'm checking to create a container, which took approximately 49 seconds. And this also took similar amount of time. And there was an error. It said container already exists. And this was another error with some other message. And I was trying to delete, but there is no such file. So this was giving some error, but that call took 9 milliseconds. So these are all individual interactions with various components within this request. Now you see all the duration here. In case if you don't see that here, probably you can collapse this. Sometimes this particular thing is not visible. Probably there's some UI issue. You see, it is not visible. Even if you scroll towards right, you don't see that number. So in that case, you make some room by collapsing these plates. We'll see that number. And here, right here, you see a profiler. Again, this is only visible when we enable profiler. Right? So I can click on this to see what happened additional to what it is shown here. You can click on this, or if you don't want to, if you're not interested in this particular session, but you are interested overall, then you should scroll towards left. We are inside performance blade, and you click on this. And for the very first time, if you want to enable it, you can click on this profile. It takes some time to install the agent on our application app service server, and it does a warm up, and then it starts the session. So it takes some time for the very first time. Right? And if you can also do some other triggers if you don't want to profile manually, you might want to do it automatically. Then you can click on this. So if you want to trace only CPU, then you can do this. It is currently turned on and it runs only for 120 seconds. So it automatically runs when the CPU threshold goes beyond 80%. It automatically runs when it reaches when CPU percentage on the server reaches 80%. Then it runs for 120 seconds and again runs only after 4 hours. Even if the CPU is beyond 80% after 4 hours, within 4 hours, then it won't run. So the next run will be only after 4 hours. And same thing you can do it for memory. And of course, you can change the duration by default is 120 seconds. You can decrease it if you want, or you can go up to only 100 seconds. So if you don't want CPU or memory, then some other, if you want to change the sampling rates, like normal, high, and max. So it captures more data when you go to maximum. It's not recommendable to do this unless you're pretty sure on what you're doing, because if you choose this maximum, it might impact the performance. So normal should be good for most of the applications. So if you change it, don't forget to click apply and you click what I have now. So I have two sessions, profiling sessions. So I can even download the trace and I can use it in some other Windows based tools. I can use this traces even in Visual Studio. Right? Sometimes this fails. Let's see. Let's try another. So these are four items which are tracked during that particular session. Is extracting the data from the event trace from the call stack. So sometimes it fails. So it gives us all the hard parts. So it automatically opens up whichever component is taking more time. Yeah, it takes time. Let's not wait because I already showed you that how this trace looks like. That's the reason why I captured all those screenshots upfront. So this is a view. You can see hard paths, right? In real-time application, there could be many uh, calls within the application. But this profiler helps the developers to directly jump into where exactly uh, which component is taking more time for the calls. That's how a profiler works, and you don't need to write any. Uh, it's not hundreds of lines of code. It's just one or two lines of code with some configurations. That's about it. I think I'm done.